we will calculate the power available at climb phase. So we will D plus W sine gamma into V. So that using this expression thus required equal to W divided by L by D. In our case L by D max was 13, but that was L by D max. We will take here L by D 10. What was the weight? 1, 2, 3, 8, right? Yes. So what is the value of this? How much value you are getting here?
1214.47.
1214.478, and plus this is 1238 into 9.81 into sine 8 degree. What is velocity? 30? 1214.47 plus what is this value? 1238 into 9.81 into sine 8 degree. Total value is how much? 1690.22. Now you observe that your W sine gamma is greater than the V. Okay. So ultimately the W sine gamma into V part will be greater than into V part. D into V part. This is nothing but the power required at a cruise. Okay. So you multiply by 1214 into 4.7 into 36.78. How much you are getting? So this will be 44668.2. Please correct me. Yeah? 6216. Right? Yes. Okay. So now you can see that this second part is more than compared to the first part. So if we select based on the engine only for a cruise, you will not be able to climb, because you need W sine gamma into V extra power in order to make the climb possible. And you should not confuse between the power required and the power available here. Because for example, like let's say you have an engine is running at a 100% throttle, for example. So 100% throttle, if it is running, then it is a maximum available power. But available power itself can be decreased by decreasing the throttle setting. If you select 0.8, there will be different power available. 0.7 different power available, and 0.9 different power available. Okay, but here V plus W sine gamma into V is nothing but the power required at that instant for a climb. And simply you can observe here, you can understand here. For example, this is a steady state level flight. If you put the throttle 100%, okay, so let's say in this condition the thrust required is power required is, let's say for example 50 watt, and if you put the throttle at a maximum, you will get the 100 watt power. Okay, so now you have excess power. How much? 100 minus 50, 50 watt. From that excess power you will try to climb, and you will reach that altitude where power available will be equal to the power required. So as long as you are increasing the altitude, your power required is increasing. So if it is reached to the power available, then you will stop attaining the new altitude. That means your climb rate will be 0. Okay. So now you sum up how much value you are getting, total value? 8468.2 plus 62166.29 is nothing but 10, 6, 834.49 watt. Okay, or you can say 106,834 kilo. Okay. So if you select the engine which is capable of producing 106.8 kilowatt, then you can climb starting from 8 degree. Okay. And we remember here when you are increasing the altitude, your power required is going closer to the power available, and slowly your gamma will try to from 8 degree to maybe 7, 6, 5, 4, 3, 1 and finally 0. Okay. So this is 106, but this is a power required to do so many things involved. For example, let's say if the engine is giving you power, for example 120 kilowatt or 100 kilowatt, you will not get that power because there will be propulsive efficiency associated with the engine, shaft is connected, so many things is there, right? So if you assume that total efficiency is all around 0.5 to be more conservative, then you can take the power available and you will put one dash and you will take this efficiency total. Okay, so 106 point how much?
37.
106.83, right?
Yes.
0.5. You just double the value. How much you are getting? Right? So that is nothing but the based on climb you have selected. You can select the engine. Okay. Now what I said, power required equal to W divided by L by D into V, right? Okay. What improves if you fly at a maximum velocity? Vmax. So we can calculate the power required because I want to cross check. For example, let's say whether if I am able to climb with this engine, which can be able to produce the 213.66 kilowatt. But if I go to the cruise condition and if you want to fly at a maximum velocity, can we do with the same engine? We will check here. We can G into V. So right, VQ S into CD. V into V square will become VQ. Okay. So let's say I am flying a sea level altitude 1.2256 and I am taking as my maximum velocity is 2 times of the stall velocity. So what is the stall speed? Can you tell me? 3 into 28.3. I am taking the maximum velocity because here I am taking V max. Power required max. Okay, so V max. Okay, so I am taking as a V max is 3 times into V stall. So 28 point. And how will you calculate CD? CD you may write CD equal to CD naught, which is nothing but the 0.05 plus K. What is K value? 0.03, right? 0.03. What is the CL value? CL value you can calculate like this. CL equal to 2W divided by rho V square S into rho V square S. You also calculate the same. 17 point how much?
60.
CL value is coming around 0.15. For how much you rule already? Same. 0.0507. That means if you are flying a very high speed, the effect of the induced drag will be very less. So you can consider CD equal to just a CD naught. Good check, right? Multiply by area. 18.6. Please check. And in client case 106. So in which case the power required is more? In cruise, right? So that means if you want to fly in cruise condition for a Vmax condition, so you have to have this much power. So you can select the engine based on this power also. For example, if you have selected the engine based on this power 335 and with the efficiency and everything, what you will get? Power available. I will put double dash here for just for we have calculated at cruise condition at 335.968 divided by total efficiency 0.5. So 671.937 kilowatt. So if you have this much power, then no doubt about climb flight, you can easily climb, because here the power requirement is 106 and with efficiency R the power required is 213, and in this case we are getting 671.936, more than 3 times. Okay, so this way you have to select the engine. That means you have to check at a normal design speed the power required in a cruise condition, and then go back to the climb flight. Based on the climb requirement, you calculate the power required to perform a climb, and then you can also check if you want to fly at a max condition, Vmax condition. Then you may go back to the again cruise condition and put Vmax, where the power among all, where the power required maximum it is coming. You have to consider that value and select the engine accordingly. Okay, thank you.